When would you use columnar databases over your typical row-wise databases? Let's explore this question by comparing row-wise and columnar databases on the following dimensions: storage, retrieval, deletion, and updation. We will use the following simple data model. We pretend we are the front office of a movie theater selling tickets to customers. The data shown on the ticket below is represented on a single table. We run all our queries against this table. Chapter 1. Storage. Storing data row-wise is as straightforward as writing the data one row at a time into a file. The row itself is written one column at a time. For both simplicity of representation and human readability, we will use the comma-separated value format, or CSV format. The ticket shown above will be written as shown below. Storing data column-wise is also simple. Every individual column is written to an individual file. The entries in each file are written row-wise. For example, given these two tickets shown below, their columnar data is written into files as below. Every file stores a column's data. The order of entries in each file matches the row order, so the first row's value is first in the file, the third row's value is third in the file, and so on. We need an index to retrieve data. We'll create an index on the primary key. The index will also be a file. It has exactly two columns, primary key and byte offset. Byte offset refers to the position in the file at which that primary key's data begins. For example, consider these tickets shown here. When we write them as a CSV, each row starts at these byte positions. The first row starts at byte position 0. And our index looks as follows. To retrieve a row by primary key, we first consult the index and find the byte offset for that row. We read the file, seek to the corresponding byte offset, and read the row. If we are only interested in some of the columns in that row, we still have to read the whole row and extract those specific columns. Indexing columnar data is similar, except we need one index per columnar file. Retrieving a row by primary key requires consulting as many indexes as columns requested. We'll explore retrievals in more detail in the retrieval chapter. At this point, you might be asking the question, why bother with indexes if we must maintain the index in a file, the data in a file, and read both anyway? That's a great question. To answer it, we take a brief interlude into operating systems theory and paging. Operating systems manage your RAM memory. Every running program, its associated data is first loaded into RAM. The OS manages this memory, and to make its life easier, it divides the RAM into fixed-sized chunks. Each of these individual chunks is called a page, and a page is typically 4 kilobytes. The OS always reads an entire page into memory, and scanning through a page is considerably cheaper than scanning through a file on disk. Here's where the index and the data file come in. The typical index will not contain the byte offset of a row, but the page offset in the data file. The 10 tickets we saw earlier would all fit in page 0. This way, an index is vastly smaller than the actual data, and is more efficient. Indexes allow us to efficiently read the relevant data files. Of course, an index needn't be a straightforward file either, but we won't take another interlude into B-trees. In this video, we don't get into any of the complexities of pages. Our sample data will fit into a tiny file, and the index will refer to byte offsets rather than page offsets. End interlude. Chapter 2. Retrieval. When would you use a row-based versus a columnar database? In the industry, there are two types of queries. Continuing with our movie theater example, I might ask, show me all the tickets sold over the last 3 days. The SQL query would look as shown here. Another example, which movies did we show on the 15th of March? On which days did we show the movie Harry Potter and the Flame Chalice? These queries belong to one category of queries. Queries of a second type are, how many tickets did we sell on Labor Day? Over the last 3 years, show me the total tickets sold each month. These two types are called OLTP and OLIP respectively, online transaction processing and online analytical processing. One returns a list of results from the tickets table, the other returns sums from the table. Row-based databases work better for transactional queries, and column-based databases work better for analytical queries. Here's an illustration retrieving this transactional query from a row-based store. First, we note that the primary key index isn't useful, so we directly read the data file, scan for the relevant dates, and return those rows. In the case of a columnar store, we must read the timestamp file, scan for the relevant dates, and capture their IDs. With those, then read every other column's indexes and corresponding data files, skip to the index byte offsets, combine the columns, and return them. That's an example OLTP query. Let's move on to seeing the execution of OLAP queries. In a row-based database, we read the data file, scan each row for May 1st, and return the count. The same 3 steps are executed by a columnar store. Except in this case, the data scanned and read is much lower. The timestamp column file's size is 600 bytes to the row data file's size of 1.4 kilobytes. Thus, while the columnar execution plan is the same as a row database, for every 100 bytes read in the row database, only 40 bytes needed reading in the columnar database. Thus, we can expect that a columnar database will be around twice as fast as a row-based database for analytical queries. Engineering is often about compromises. A columnar database stores more data on disk than a row-based one, but performs better for analytic queries. Given the ever-decreasing cost of storage and the ever-high premium on time, columnar databases are useful. I won't go into deletes and updates on both database types. Thank you for watching. If you enjoyed this video, click the subscribe button and enable notifications. And if you learned something new, chances are your friends will too. Do share.